All right. Good morning, good afternoon, good evening, wherever you are. I am Nick Chase from Mirantis, and I am here to bring you today's webinar. Well, not really webinar, our live demo. So let me introduce you first to today's presenters. We have Ivan Shvedinov, who has done a lot of work on kubeadm-dind-cluster, and Michael Tillman, Senior Systems Architect here. And of course, Ivan is Senior Software Engineer here at Mirantis. They're going to be giving you an overview of this project and how it works, and also kind of give you a feel for some of how it fits in with some of the things that we do here at Mirantis. Now, before we get started, a little bit of housekeeping. As you are probably familiar with, there's a place to submit your questions on the right-hand side, usually on the right-hand side. We're going to hold all of the questions for the end after the actual live demo. And I do have to say, by the way, this is one of my favorite projects. So I'm very excited about this. So if you have any questions, please go ahead and put them in the questions pane, and we'll get to them at the end. And you will be able to download the slides at the end. Okay, so a little bit of an agenda here. As I said, we're gonna Mike's going to give us an overview of Mirantis Cloud Platform, and kind of give you a little bit of an explanation of how KDC fits in with that. And then Ivan is going to show us KDC and give an overview of how it works, and you will see it actually in action. And then if you have any questions on what you can do with it, if he hasn't covered that already, how it works, how you can customize it. Again, this is one of my favorite projects. So pardon my enthusiasm, and we'll just move right along. So Mike, tell us, I'm going to hand this over to you now
Okay.
to talk about MCP.
Perfect. Thanks, Nick. And I just wanted to welcome everyone today, and thank you for taking time out of your busy days to spend a little bit of time with us. And as we deliver this live demo, and of course, as everyone knows, that anything can and usually does happen in a live demo. So we are going to know that everything is going to align just perfectly, and the demo gremlins are going to stay away from us. So it's going to be a.
Did you sacrifice the live chicken?
Well, I did not, but
all right. Well, we'll keep our fingers crossed.
we'll cross them up. So at any rate, it's thank you again, everyone, for spending a little bit of time with us. So what I want to talk about from the perspective of what MCP and the Mirantis Cloud Platform is, and what it does for your organization as a whole. What we have here is, what happens inevitably in any type of organization. What you have is you've got workloads that are putting real world constraints upon your system and upon what it is that your what your application needs and what you can deliver to it. So your business applications dictate the unique infrastructure requirements needed by you and your organization to provide the best possible experience for your customers, right? So these real world constraints, with, for an example, existing hardware investments, preferred suppliers, limitations imposed by networking, security, compliance, and everything of the like. Most prepackaged vendor solutions don't fit within your type of constraint, and a DIY type of approach is time consuming, cost prohibitive, and it usually ends up in being kind of a mess. So one of the things that we like to look at is using these types of different use cases to provide to you and your organization our expertise to help you get this balancing act into equilibrium, so you can handle the real world constraints and satisfy all of the application requirements. Next slide, please, Nick. So, how do we do this? So one of the things that we like to do here is we provide flexibility with predictability. And so what this is we have three major components within Mirantis Cloud Platform, and those three components are drivetrain on the left-hand side in the purple, and that's our lifecycle content management tool. And in the center is basically our flexible infrastructure. So what we have there is it's the virtual compute, it's the virtual networking, the virtual storage, and everything that you would expect to see from Kubernetes that Ivan is going to talk about today. And we expect this to be flexible, and I'll explain a little bit more about that in just a second. So, and on the right-hand side, Stacklight, which is our OSS tool or our logging, monitoring, and alerting platform. And what this is basically is it gives you the capability to be flexible by delivering this LCM idea via drivetrain. And it allows you to do not only the zero-touch upgrades that you would expect to be able to do with Kubernetes, and it gives you this LCM delivery CD portion and the day two operations being in the non-disruptive sense. So the day two operations can be performed upon your entire Kubernetes infrastructure without doing any type of destruction to it. So you can do all of the things that you would expect to do a day two operation wise. Now, if you, all of these day two operations ideas are great, right? But if you don't know when to make these type of upgrades and updates, excuse me, if you don't know when to do those, then it's kind of a lost point. So what we do with Stacklight is it gives you that insight into your infrastructure, and it gives you the insight into your Kubernetes clusters, and it ties everything together, and it gives you this either graphical or from a log perspective on what is going on with inside your cluster. Okay, next slide, please, Nick. And so, and just to retouch again, what this is for any type of workload that you see or that you have as an organization, it harnesses the open source power that we provide to you with our solution. And if you need to use the latest innovation in infrastructure for a competitive advantage, so say to make money by capturing new customer needs, or by saving money by reducing costs to serve your customers and their requirements. So you need to continuously integrate the latest technologies, the latest systems with minimal downtime, and that's where drivetrain and Stacklight come in, as I was just referring to. So we basically deliver into the development environment, and based upon the resultant change in the development environment, then we know exactly what's going to happen, how it's going to transpire, and how that change to your infrastructure is going to affect your overall environment. So we can very confidently do the same deployment, because it is a true CI/CD tool chain that allows you to know that whatever changes that you make in the development environment is the same exact thing that's going to happen in the staging environment and in the production environment. So we can do that very confidently. Next slide, Nick. And so just to talk about the overall infrastructure here, this is the overview that I'd really like to drive home here, what the Mirantis Cloud Platform really is. And so again, I've been talking about it quite a bit here, but just to really press home the overarching idea here, if you look in the center where the flexible infrastructure is at, the open cloud software, we have basically Kubernetes that we use a container orchestration platform with Calico as the layer 3 SDN CNI, and of course Ivan is going to talk more about that here in just a second. And then we use software-defined networking, software-defined storage. We like to talk more about that software-defined storage as Ceph, and the software-defined networking is what we like to use from the default for Kubernetes using Calico. So Drivetrain again is a open source tool chain that we like to use. It's a very widely used open source CI/CD components enabling all of the different type of lifecycle management tools that you would expect to see. And again, everything is open source. So Stacklight, again, on the right-hand side, logging, monitoring, and alerting. We use all of the associated log aggregation tools, databasing, analytics, visualization tools such as Grafana, such as Alerta, such as Prometheus. So but the main thing I want to point out here is that we have invested not only a bunch of time but money, and we're upstreaming all of these type of changes into the Kubernetes infrastructure and the Kubernetes community. So we're all in as far as what it is that we're trying to accomplish with Kubernetes and all of these different types of projects that we're doing and contributing to at this time. Next slide, please, Nick. And so the last item that I'd like to speak to you about from the MCP perspective, and with the emphasis being here on Kubernetes, just the high level LCM type of flow and how we use Drivetrain and how this all functions together. So what happens is that, so say for example, Ivan is making a code change to the Kubernetes cluster, and he makes that change and checks it into Git. Git is what we use as our code repository, and so basically it gets checked into Git, and then from Gerrit, what we use Gerrit for is our code review tools. And so from that code review, we have senior level people make these reviews on the code that's been changed. So and then from there, it's an automatic trigger that will kick off this Jenkins job, and then SaltStack is what we basically use to as the orchestrator to deploy these changes to your Kubernetes cluster, or OpenStack for that matter. So this is basically just a hierarchical 10,000-foot overview of how Drivetrain can day 0, day 1, day 2 type of operations provide to you and your Kubernetes cluster the type of touchless upgrades that you'll expect to love from Mirantis. So without further ado, I will kick it over to Ivan and let him get...
Before we kick it over to Ivan, I just want to ask you one more question. Can you talk a little bit about Vertlet, because Vertlet is pretty relevant in this to this demo?
Sure. And so what I'm going to do is I'm going to let Ivan talk about Vertlet from a technical perspective, and I will let Ivan take care of that. Okay. Since that's going to be part of his demonstration as well.
All right. Well, there we go. So I'm going to go ahead and give over control to Ivan, but let's do that. Where are we here? Okay. All right, Ivan, it's all you. Take it away. Go ahead and share your screen and we will be set. Good.
Can you see my screen right now?
Yes, we can.
Cool. So my name is Ivan Shudunov, and I'm going to show a demo of kubeadm-dind-cluster, which is a local Kubernetes cluster test tool. A few words about this project and why it's needed. Basically, it can lets you run a local Kubernetes cluster, and all you need is a Docker engine. Unlike many other tools, it can run multi-node clusters, and it can even run multiple clusters on the same Docker engine. It does not require many resources thanks to Docker and Docker techniques, and it works on Mac and Linux. And what's important, you can use a remote Docker engine for your work. So you can run the script itself on your laptop while all the heavy lifting is done by a powerful remote server. A few words about other local cluster solutions. For instance, there's Minikube, but Minikube gives you only a single node, and it's also hard to build Kubernetes from source for use with Minikube. And kubeadm-dind-cluster has this part covered too, so you can easily build Kubernetes from source. More on it later. And there is also Kind, which comes closer. It's a rather good tool actually, which also uses Docker and Docker, but right now it has no remote Docker support, and as far as I know, you can only use Weave as your CNI implementation for the networking. And also there's a tool widely used by Kubernetes developers called Local App Cluster, but it's tied to it's a part of Kubernetes distribution. It gives you a single node, and it has multiple limitations. It's basically not considered a real Kubernetes cluster. So let's start the demo itself. Here for this demo, I'm using a GC instance with a Docker engine set up. Basically, I forward a couple of ports and a Docker socket to the GC instance. Let's check that it works. Yes, it does. Let's start the cluster. I'm actually restarting it here to make it quicker. It could take maybe 3.5 minutes here to start it initially, but it will be about a minute. It will take about a minute to restart it. So here we just start the script, and it takes care of starting the cluster. First, it stops the previously running one. Now it creates a Docker container per node. Every node is just a Docker container here. Sets up networking. Second. As you can see, there are no VMs here. While it starts, we can run Docker PS and see there are just container per node. There's another cluster running. Let's also restart it. I'm not starting it from scratch again because so as to make it a bit faster. So let's start another cluster right here. We just pass another cluster ID and use different API server port, which we also forward over SSH here. So here we have this cluster up and running.
So basically, with two command line statements, you've created two independent Kubernetes clusters with multiple nodes each.
Yeah, that's correct. So we have two clusters with 3 nodes here. So this will work for a lot of situations. It may work a bit worse in case if you need to do something advanced with Kubernetes resource allocation, because there are some limitations related to cgroup handling in nested Dockers. But for the most cases, it will work just fine. So why you may need multiple nodes? First of all, if you're an application developer, in some cases you may want to see how your application behaves with multiple nodes. In some cases, you may need to use host networking for some of the pods or something like that, and you may want to make sure that it will work just as well across multiple nodes as it works on single node that, for instance, Minikube can give you. Another point is testing Kubernetes extension. I'd like to mention the project called Vertlet. Actually, I already mentioned here. It's a container runtime implementation that makes it possible to run VMs on Kubernetes as if they were plain pods. So you can take Q2 image and run it as if it was a pod. You can make deployments of VMs and so on. And we are using kubeadm-dind-cluster extensively to test Vertlet, both on CI and during local development. And of course, it's quite useful for working on Kubernetes itself. For instance, if you're hacking on some scheduler extensions, you may need multiple nodes to test them. That's obvious. So as I already did show in the live demo on my terminal, you can set cluster ID, in case of remote Docker also API server port, and you can have multiple clusters after that. So we can view pods in a different cluster here, and if we remove this context, it will be the first one. They look similar, but those are two different clusters here. Next, remote Docker engines. As I did show, the clusters run through on a GC instance. So if you have like 8 GB on your laptop, it may not be enough for Kubernetes work. But if you have a powerful server or a cloud instance, you can use it perfectly for your Kubernetes-related tasks thanks to kubeadm-dind-cluster. While you can still run the script itself on your machine, use kubectl from your machine, and you don't have to SSH around all the time. So you can use your local editor without any need to edit remote files, stuff like that. It also does not use much network bandwidth. From my experience, you can use kubeadm-dind-cluster even over rather slow 3G links. So with the good remote machine, so it's it will just work. All you need is just forward several ports over SSH. Another important thing, I will sadly have to skip it from the live demo because it would take more time. And currently there seems to be some changes in Kubernetes master that I'm working to make kubeadm-dind-cluster compatible with, but it will be fixed very soon. Yes, another important feature is that kubeadm-dind-cluster can build Kubernetes from source, and it can do it rather quickly. It can do it on the same remote machine that you run your Docker engine on, and it will run the cluster there without copying back the binaries to your machine. So for instance, if you hit a problem with your app after upgrading to a new Kubernetes release and you want to find the PR in Kubernetes itself that caused the problem, you need to use git bisect, and you must build Kubernetes like 10 times in a row and restart the cluster. And with kubeadm-dind-cluster, you can do such tasks without spending a day on it. Another point is using kubeadm-dind-cluster with public CI systems. It works for us on Circles with Circle CI and Travis CI, but I think it will work with different CI systems just as well. Thanks to remote Docker support, you don't need to have real VMs in case of Circle CI. This machine executor type may become a paid feature there, but you don't need it for kubeadm-dind-cluster. You just need remote Docker mode. So let's take a look how does it happen in real life. So first of all, here are the Circle CI jobs for kubeadm-dind-cluster itself. As you can see, we tested with multiple Kubernetes versions. It supports versions 1.10 through 1.13 right now. And here you can see the job. And even though Circle CI does not give you very powerful machines to test stuff on, it takes just 5 minutes to start the cluster here. So you can see the cluster does start up as a during Circle CI job. And here's a successful build for Vertlet, where you can see multiple jobs that examine the extension with different container network interface implementations with Flannel, Calica, Weave with multiple CNIs. It's all important because in case of Vertlet, you need to have special handlings for some of the CNI implementations to pass them to pass the network settings to the VM. So it's important to test as many of them as possible here. And also, if we go inside the job, we can see the cluster starting here. Next, diagnostics. When you use a tool like kubeadm-dind-cluster for CI, in some cases, if the job fails, you may still want to examine the state of the cluster post-mortem. So the cluster is no longer here, but you still want to extract the information from there. So let's take a look on how it happens. For instance, let's take a job from KDC itself, and we go to artifacts, and we have cluster state stored here. It's done using dump subcommand from the DND cluster script. And so let's download it here. There are 2 dumps after at different stages done. And here we just run the split command to get to the content of it. And here inside the cluster dump directory, we can see a lot of files describing the cluster state. For instance, kubectl describing all the pods, and you can also view pod logs of the kubelet, and the other important information that can you help debug a problem on a cluster that's no longer here. So from my experience, it's quite an important point. And next to the networking part. So KDC has support for multiple CNI implementations with Calica, Flannel, and kuberouter. The latter one is a bit limited right now, but I think we will fix it soon. And also you can test rather interesting aspects of Kubernetes networking right on your test cluster, one of which is MetalLB, which is I'm going to show you as a part of the live demo. So here in this directory, we have this MetalLB configuration file that sets up Metal LB in layer 2 mode. Metal LB is something that makes it possible for you to have load balancer services on a bare metal Kubernetes cluster, but you may want to test it on KDC too for different reasons, because maybe you want to test something related to load balancer services. So it just gives an address pool to Metal LB, and let's apply it. And here it is already running in Metal LB namespace. So here we have this Nginx deployment and their service of load balancer type. So here we have this Nginx deployment running. Now you see the Nginx service received an external IP from Metal LB, and in order to check it, this time we must go to the GCE instance we are using, because we are not forwarding any ports for it, but we could. I just didn't do it for the sake of simplicity. So let's try it, and we see this message from Nginx right there, accessible on this load balancer IP. So I just demonstrated using a rather advanced networking tool with some effort. I think there will be better support for it later. You can also run Ceph on KDC and other interesting tools too. So there was some effort to run Rook on it, for instance, but well, still needs some work. Concerning container runtime interface implementations, right now Kubernetes supports multiple container runtime interfaces. It's Docker by default, but you also use containerd and CRIO, for instance. And if you want to test containerd for your application or a Kubernetes extension, KDC can help here. It supports containerd out of the box, so you just pass dind CRI containerd environment variable, and you will have containerd instead of Docker. You can also test other CRI implementations. For instance, Vertlet itself is one example. It implements CRI to run VMs as pods. So we use KDC to test Vertlet too. So that's all for my part. Thanks. Any questions?
Wonderful. Thank you so much. All right. So, all right, we're going to go ahead and take some questions now. So, if you have any questions, please go ahead and put them in the questions pane. We're going to go ahead and collect those up. We've got a few to get started with. Let me go ahead and pull those up. Okay. So, while we're getting questions, let me go where we have here. All right. So we have a few people who are asking, is there a guide? Where can we get the scripts to play around with this? In addition to the actual documentation, there is a blog post. And Michelle's going to go ahead and paste the URL into the chat, but there's a blog post that gives you a sort of quick and dirty guide to using this, and it gives you a chance to download the scripts and start up the clusters and so on. So you can take a look at that. All right, so let me move on to some of the other questions here. Mike, technically, what is Stacklight made up from?
Hey, Nick. Yeah, so that's a really good question. And one of the things that, before I answer that, it is, of course, comprised of 100% open source. All of the pieces of Stacklight, as well as everything within our solution, is all open source. And so some of the things that Stacklight is composed of is Telegraph, Prometheus, Prometheus long-term storage, Alert Manager, Grafana, InfluxDB, and of course Docker. So those are the main items that that are composed, that Stacklight is composed of. So it's a very robust system and a very robust and very important portion of our toolchain.
Okay, excellent. Thank you so much. All right. Now, Yvonne, we have someone asking, can you show us how it builds from source? So this is a demo, so this is a good good time to ask that question. Is that something you can show us now, or is that something that takes too much time and you just need to explain it a little? Yvonne, you appear to be muted.
Sorry, can you hear me now? Yeah. So I can try to show it. I will probably not wait till completion.
Okay.
Can you let me share my
We're going to
screen
give you
again?
back control here. All right, it's all yours. Go for it.
So I will try if I list. So we need to pass several settings here. Namely, we build kubeadm and build hypercube are important. This rsync compression is not, and this also. This. So basically, we started like this. I'm afraid it will take quite a bit of time to build Kubernetes. So in order to show how it really goes, I can show you the completed job.
So go back to the command line for just a second, if you don't mind.
Okay.
So am I correct in saying that basically all you did to get it to build Kubernetes was just add those two command line switches, basically? You just told it to build, and that's it, and it builds Kubernetes.
Yeah, it basically builds Kubernetes, and you don't need any extra tooling for it because it uses the standard Kubernetes build container. So you don't need to install different
Have I mentioned that I love this tool? This is great. Okay, I'm sorry. Go on. You were going to show in Circle CI.
So in Circle CI, let's second. Let's select this here. So this master build from some time ago. As I said, there's some minor breakage on current Kubernetes master. Unfortunately, there are often changes between releases that I have, after which I have to fix my scripts, but I fix it by each Kubernetes release. So in some cases, master may not build, but in that case, it went just fine. So let's check. It's checking out Kubernetes source and bringing up the cluster here. The log is quite big, so Circle CI will not show all of it. It builds Kubernetes right here on Circle CI, as you can see with this VM. Check how much time did it take in this environment. I think it was a rather long job. Yeah, it's like 11 minutes here, but nothing too complicated. Of course, it will take more time than starting using pre-built Kubernetes images. But well, actually, the trick is just these two environment variables. that's basically it.
Okay. That is fantastic. All right. So should we take back control here? All right. So let's do that. Okay. Let's go back to questions. Can this be used, Yvonne? Can this be used with Docker for Mac without remote Docker?
Sure, you can use it with local Docker just as well. So the difference with remote Docker is that you just set Docker host and other parameters needed for Docker connection, but it can work with local Docker just as well. It can work with Docker on Mac, for instance, without any problems. Or it can work with usual Linux Docker. So, for instance, on this GC instance, I could just run it locally.
Okay. All right. Let's see. So is this going to work with Docker Desktop for Windows? Someone would like to know.
Well, unfortunately, I didn't test it much with Windows. Some people tried it at some point. It used to work, but I think it should not be hard to make it run there. But well, contributions are welcome in this area.
Okay.
If you have a Windows machine.
Everything is based on Docker, so in theory, it should work, right?
Yeah, it's the main script is just a bash script. So as the bash works on Windows, it should probably work. But well, there are maybe some tricks necessary.
Gotcha. So would it maybe work with Cygwin, where you can run,
Well, I did. It was a long time ago when I last time used Cygwin, so I can say.
So it may work, may not. Okay, but definitely contributions are welcome. All right. Is there a man page, like a functional description with options and so on?
Yes, you can just go to the home page. I can probably paste it in the chat.
Yes.
It's a GitHub page that has a description of how to use it. So
the documentation is actually very good.
I can
with some other projects.
Looks like I can send it to everyone in the chat just as an ISER's presenter.
Okay.
Yeah. Here it is. It's under Kubernetes 6 umbrella, and there are some examples of how to use it, description of the options.
All right. Wonderful. Okay, let's see. Where are we? Is the recording of this session available later? If so, from where? Yes, you are going to get a recording of the session. So if you need to drop out, that's that's okay. Okay, what is the relationship to kube control?
Well, the relationship to kube control is that kube control is the tool that you need to use to access your cluster. kubeadm-dind-cluster takes care of downloading kubectl for you in case of if you use one of the fixed images. So it will put it into a subdirectory of your home directory. So it's kind of automated. It will pick the right version for the Kubernetes version that you want to run. And in case of if you are building the Kubernetes from source, it will build kubectl for you too.
Okay, excellent. All right, let's see. Okay, we have a question here. How to evaluate this is all that it says here.
Well, basically go to the home page and there is brief instructions how to download the script and run it.
How to evaluate this? Yes. Sorry. I'm reading the sentence, and yes, it's early here. Okay. Let's see where we are. Yeah, so you just go to the homepage and grab it, or you can go to the blog post, which also gives you a link to it. Why in your CI are all of the 3 CNI plugins compiling?
Well, we don't compile CNI plugins, if that's the question, but we check the cluster against different CNI implementations to make sure they run in DINT environment. That's speaking about the CI of KDC itself. And speaking about Bertlet, as I said, the VMs don't understand CNI. So you basically need to do some tricks, and they differ between different CNI implementations. So for instance, for Calica, some extra care must be taken. There's internal DHCP server and Vertlet and stuff like that. So we must make sure that every CNI implementation is handled properly. So we basically want to make sure that things don't break on different CNIs. That's why we are using different CNI plugins in our CI.
Okay. Somebody asks if all the documents and the images can be shared. I assume that's the slides and images for the webinar, in which case, yes, we're going to mail that to you. What Kubernetes versions are supported?
We support Kubernetes versions 1.10 through 1.13 currently. And I try to support the new Kubernetes version as soon as possible after it's released. So after 1.14 comes out, it will be supported shortly too.
Okay. All right. Mike, we had a question here. Can you send the list version of tech components? You had a slide with that, didn't you?
Yes. So, and not only that, but I can send all of the versions, or I can just put I can put a link to we have a one particular place in our docs.mirantis.com that will give you the latest versions and all of the versions of each of the components that we put in each version of MCP. So if you're wondering, what version of Telegraph that we used, or what version of Docker that we're using currently in this latest release, then we have a website that has all of those particular versions for each of the releases for MCP.
Okay, excellent. Yvonne, can you show us how to configure it to run in Travis CI, or is that something that's a little too much for this demo?
Well, you can configure it like this. Frankly speaking, last time.
Hang on, let's get you showing your screen again. Hold on.
1 second.
Okay, all yours.
So in the current master of kubeadm-dind-cluster, there seems to be a bit of difficulty with Travis, but it's, so to speak, temporary condition. The configuration itself is simple. You just need Docker service. This LZ4 tool is needed only for building kubeadm-dind-cluster itself. And if you use Docker, the KDC will just work on Travis.
Okay,
So,
well, sorry, go ahead.
Well, basically that's it. There may be some difficulties currently with the latest version, but I will recheck this part just in case.
Okay, all right. Well, if you have any more questions, now is the time to drop them in, because I believe we've gone through all of our questions now. So let's see here. Let's see here. Okay, so there's a link in the chat now for the list of tech components and their versions and so on. We'll make sure that that also goes into the email. All right, well, let's see here. I think we're going to wrap up early. Okay, so yeah, so if you have any questions, you can email Michael. His email is on the screen right now. And if it's a question for Yvonne, he'll pass that on as well. Otherwise, we're gonna hereby remand you 7 minutes of your life. So thank you all very much for joining us. We know you're all very busy, and we hope that you'll join us next time. So again, thank you very much for joining us. Thank you to Michael Tillman and Ivan Shvedinov, and of course our super producer Michelle Yakura, without whom we could not do any of this. So thank you all very much, and we will see you next time. Thank you.